Okay, so next up we are going to look into getting the phasor version of the capacitor. And we start with our standard equation here that relates current and voltage. And we'll say, okay, well, what if my voltage is, some radius e to the j omega t like before? Then the derivative of that is r e to the j omega t times the j omega from the chain rule, which is the same as saying j omega times the original voltage. So that means, taking this equation here, we have phasor I is j omega c phasor v. But remember, we want voltage is I times z. So I need to divide here, and I get v is 1 over j omega c times I, which means my impedance for a capacitor is 1 over j omega c. Okay, so that means we are dividing here instead of multiplying, but that's what our impedance is going to be for a capacitor. And what that's going to do is going to cause, in this graph, instead of the voltage to be 90 degrees ahead of the current, it's going to cause the current to be 90 degrees ahead of the voltage. And that's going to cause over here the current graph to reach its maxes and mins first before the voltage does. And so for capacitor, we say that the current leads the voltage, or we can say that the voltage lags the current. So just to summarize here, that if you have a resistor, Z is R. If you have an inductor, Z is j omega L. And if you have a capacitor, Z is 1 over j omega C. And sometimes we prefer writing this as negative j over omega C, which you just do with some complex number arithmetic there. So it depends if you want the j on top or not. It becomes negative j on top. But regardless, these are the three things we need for converting our circuits into phasors.